Hello, my dear students. Welcome to PW English Medium Class 9th and 10th YouTube channel. My name is 𝐂𝐇𝐀𝐍𝐃𝐄𝐍. I'm your physics teacher. Students, in Phoenix batch, already we have completed first two chapters, that is motion and force and laws of motion. And today we are going to discuss about a third chapter in physics, that is the gravitation. Okay, so without wasting our time, let's get into the topic. So today we are going to discuss about third chapter in physics, that is the gravitation, and a subject, that is in science we are talking about a physics portion, that is the third chapter, gravitation, and batch name you can see Phoenix, and this batch is purely for class 9 the students CBSE board. Okay, and this is going to be our one short lecture. That means we are covering all the concept in one stretch. Okay, so that means we are covering entire NCERT topics in this particular chapter. Okay, so that in today's topic we are going to cover the first topic, that is universal law of gravitation. After that, acceleration due to gravity. Then we are moving with mass and weight. So here we are going to discuss about what is the difference between mass and weight. And the last one, pressure. Okay, so pressure in solids, pressure in liquids, pressure in gases. And the last one, Archimedes principle. So this Archimedes principle is very important. Okay, so by this concept, we get to know why some bodies floats on the surface of water, some bodies are submerged inside the liquid, and some bodies sink to the bottom in the liquid. Okay, so let's start with a very first topic, that is universal law of gravitation. Okay, so before that, in the first chapter we have learned about motion, where we have discussed about so many parameters with respect to motion, like distance, displacement, then speed and velocity, then acceleration. In the second chapter we have discovered what is the cause of a motion, that is force. So after that, we have discussed the laws of motion, that is related to Newton's laws of motion, that is a total three in the numbers. Okay, Newton's first law, Newton's second law, Newton's third law. Okay, so Newton's first law indicates qualitative discussion of a force, and Newton's second law discuss quantitative discussion of a force, and Newton's third law, which indicates or discuss about the nature or a behavior of a force. Okay, now here before starting universal law of a gravitation, here we have some question. Okay, we have some questions. The first question, why there is a motion of an object, means what is the cause of motion of object. Okay, what is the cause of motion of an object or body or particle? And the next one, why there is a change in a speed or velocity of the body. Okay, that means if the body is moving with a uniform velocity or speed. Okay, so if there is a change in a speed, what is the cause of it? Okay, and if you throw anything vertically upward, or anything when you throw vertically upward, why it is coming back to the center of earth, means why it is coming down. Why there is an apple, okay, there is an apple, why it is falling down when it is detached from the branch of the tree. Okay, and here we have a few more questions with respect to these diagrams. What is the cause of revolution of these satellites? Why these satellites revolve around the earth? And here we have one more example, why there is a revolution of earth around the sun. Or else you can say, what is the cause of revolution of planets around the sun? Okay, so what is the main reason all the planets go around the sun? What is the reason the moon goes around the earth? In all the examples, in all the cases, we can conclude the cause, main cause is, that is the force that already we have learned in the second chapter. Okay. In all these cases, there must be some force acting on the object, the planets, and on the moon. Here example I have considered. Here Earth, that is the planet, and here satellite, natural satellite for our Earth, that is the moon, right? Okay. Now, we got to know if there is a motion, if there is a change in a motion, means if there is a change in direction, if there is a change in velocity, or if there is a change in a speed, the main cause is, that is a force. And there are few more examples. If the body initially in the state of rest, if it is coming into the motion, what is the cause of it? Still it is a force. If the body is moving some certain speed, say 100 km per hour, okay, if it is a keep on reduces, the speed keep on reduces, what is the cause? Again, the reason is a force. Okay. And in these two particular cases, that is the one Earth, another one is a satellite. Okay. If they are revolving around, here if we consider this Earth is revolving around the sun and these satellites are revolving around the Earth, what must be the reason? What is the cause of it? Still it is a force. But what type of a force? That is a gravitational force. Okay, so we are going to discuss about this gravitational force in detail. Okay, now so here there is a one scene. Okay, here we have a a Newton. Already you people know that is Sir Isaac Newton. Okay, so just imagine one day. Okay, it is like a story based. Okay, one day Newton was sitting under the tree. Okay, so one apple detached from the branch of tree, it fall on head of the Newton. He was like, what? He checked, that was apple. And he hold that apple and was thinking, why this apple fell on my head? Okay, if that is the force, if apple is attracted by the earth, and why can't this apple also attracted towards that apple? Means if there is a force, okay, if there is a force between these two, means one is earth and another one is apple. If earth is attracted that apple towards it, okay, why can't this apple attract this earth towards apple? This was the question raised. Okay, and he concluded by the Newton's second law, that is given by F is equals to ma. Yes, of course, there is a force between apple as well as the earth. It is the same force, that is a gravitational force, and this is equal in a magnitude. Means whatever the force exerted by the apple on the earth, the same force exerted by the earth on the apple. But in this case, what happened? The apple fell down. Means apple moved towards the earth, but earth did not move towards the apple. What is the reason? Again, it is the Newton's second law. What does that Newton's second law says? The force produced, okay, the acceleration produced in a body is directly proportional to the force. Okay, and if there is a more force, there will be more acceleration if the direction along the motion of the body. Okay, if it is the opposite, then the acceleration will reduce. Okay, that we call it as a retardation. And if you want to eliminate this proportionality, you have to add proportionality constant, that is the ma. M is the mass of the body. Okay, and if we consider same force acting between earth as well as a moon, sorry, earth as well as a apple. Okay, let me consider force exerted by apple. Okay, force exerted by apple. So here mass of the apple and acceleration of the apple. Okay, in the same way, force exerted by the earth, okay, force exerted by the earth, that is equals to mass of earth and acceleration produced in a earth. Okay, that is AE. According to Newton's third law, Okay, according to Newton's third law. To every action, there is always equal and opposite reaction. If this earth is exerting a force on apple, that means apple is also exerting a force on earth. Equal in magnitude but opposite in direction. If I consider that concept, okay, so force due to earth and force due to apple. Okay, so by the concept, if you see, okay, so that is force due to earth. If we consider force due to earth, if I consider, that is a mass of the earth and acceleration produced by the earth. Okay, and the same way here f is a constant, right? In both the cases, let me consider a constant. Okay, this is the constant, so this can be written as MEAE, and acceleration produced in earth is inversely proportional to the mass of the earth. In the same way, if I consider acceleration of apple, okay, acceleration of apple, if I consider, that is inversely proportional to the mass of the apple. And if we consider mass of earth is much greater than mass of the apple. Okay, mass of the apple. So more the mass, less will be the, see, if acceleration, okay, if it is a more, that means the mass of earth is less. Okay, so not earth, just I'm writing acceleration. If it is more, that means mass is less. Okay, if acceleration is less, mass is more, inversely proportional. If we compare mass of the earth and mass of the earth as well as the mass of the apple, here we can consider, mass of the apple is negligible compared to the mass of the earth. Yes, of course, there is an acceleration produced in the earth, but it is comparatively very small. So that is the reason apple fell towards the center of earth, and this earth do not move. That means there is a motion, but very small, slightly. You cannot imagine. Okay, you can consider it as a negligible. Okay, so therefore we can observe only apple is moving towards the earth, not earth is moving towards the apple. Okay, got it. So let's read this statement once. Newton was sitting under a tree and apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both cases? He conjectured that the same type of force is responsible in the both cases. He argued that at each point, okay, of its orbit, the moon, here they have considered, instead of apple, they have considered moon. Okay, so this is the moon and this is the earth. Okay, moon falls towards the earth instead of going off in a straight line. So it must be attracted by the earth, but we do not really see the moon falling towards the earth. Reason being, that is the mass. Okay, got it? Now, next topic, that is the centripetal force. Centripetal force. Okay, so let's consider. Okay, let's consider. This is the circular track of radius r. Okay, fine. And if I consider one particle, okay, if I consider one particle, this is the particle, and the particle is in motion. So at this particular position, what is the direction of velocity? You can see this is the direction of velocity. Okay, so this is the motion of the particle, or a direction of velocity. Okay, so this is how it is moving. But what is happening? Instead of a moving straight path, it is moving in a circular track. How can we know that it is moving in a circular track? By the path. Okay, at this particular point, okay, let's consider 4 points around the circular track, and at this particular point, okay, at this particular point in the direction of a motion of a particle, this. Okay, so this is the direction of velocity, and this position, the velocity of the particle in this direction, and at this particle, okay, so this is the direction of velocity. Okay, this is the direction of velocity. And here you can observe at every interval of a time, the particle keep on changing its position. And you can ask, sir, what is the reason for that? Why it is not moving in a straight path? Why it is taking a turn? Or else why it is changing its direction at every interval of a time? That we have learned in the last chapter, right? So that is, there is a force acting on this particle towards the center of the circular path. Okay, so here you can consider there is a force acting towards the center of the circular track that we call it as a centripetal force. Okay, centripetal force means centripetal force. Okay, centripetal force. Centripetal force means center seeking force. Center seeking force. Okay, centripetal force is nothing but center seeking a force. So this is the main reason why the particle keep on changes its direction at every interval of a time. So it is a circular path. And just imagine if there is no centripetal force, what will happen? This particle move tangentially, or else this particle will move in a straight path. Am I right? Just imagine, take a one thread and tie with a stone. Okay, tie the stone with a thread and start revolving it. Okay, so that stone will be performing a circular motion. Okay, circular, uniform circular motion. If you leave that thread, okay, if you leave that thread, what will happen? It will move a tangential in a straight direction. Yes or no? And what is the reason? Before it was moving in a circular path, but after you leave it, after you break the thread, after you remove a centripetal force, it is moving a straight path. So that means if there is no force acting on a particle, it would have moved in a straight path instead of a circular motion, right? So main cause of this uniform circular motion, that is a centripetal force. Okay, and on this particular position, okay, in this particular position, let me consider this particular position. There are two forces are acting. Okay, there are two forces are acting, and already we know that the first one is the centripetal force and the next one centrifugal force. Okay, centrifugal force. This is the centrifugal force. Okay, centrifugal force. This is the centrifugal force. Okay, so this is a centripetal force and this is the centrifugal force. Then what about centrifugal force? Centrifugal force. Centrifugal force. Okay, centrifugal force. Centrifugal force means center, means the force seeking away or the force acting away from a center of the circle. Okay, center away seeking force. Center away seeking force. That means if there is no centripetal force, the particle would have moved in a straight path. Means it is always moving away from the center of the circular path. So that is the reason we call it as a centrifugal force. And the washing machine, okay, washing machine will be worked on the principle the centrifugal force. Okay, washing machine. Got it? And it is not required for your class 9th syllabus. Just I'm giving information. Got it? Now centripetal force and centrifugal force, it is understood. That means if there is any particle or body or an object, if it is moving in a circular path, how many forces will be acting? Two forces will be acting. What are those forces? First one, centripetal forces, that means center seeking force. The next one, centrifugal force, center away seeking force. Okay, so what is the magnitude? The magnitude of a centripetal force, okay, centripetal force, I'll write FC and FCF. Okay, centripetal force and centrifugal force are equal in a magnitude. Okay, equal in a magnitude but opposite in direction. Equal in magnitude but opposite in direction. Okay, Opposite in direction. When the equal forces are acting but opposite in direction, what is the net force on this particle? So here net force on the particle will be 0. So that is the reason it is keep on moving a uniform circular motion. Okay. If there must be a change in, okay, if there is must be a change in velocity, okay. So why? Because it is keep on changing its direction. It is moving with some speed, okay. We understood, okay. We understood. It is changing its position at every interval of a time. That means in this particular situation, speed is a constant, okay. Speed is a constant. Sir, how can you say that speed is constant? Let me write. Speed is given by distance divided by time taken. Okay. Let me write a distance divided by time taken. And what is the distance? For one complete circular path, okay. One complete circular path, we can consider circumference of a circle, right? What is the circumference of a circle? 2 pi r divided by, because the radius r, and a time, that is the t. See, radius is constant, and just here you need to substitute the time at every interval of a time. What is the speed? Okay, so speed will be given by, this is a distance divided by time. Distance is nothing but a circumference of a circle, that is the 2 pi r, and it divided by time. So this is the speed. And what about velocity? Velocity is the changing. Velocity is a changing. Velocity changing. Okay. Reason, because the direction. Because the direction. At every interval of a time, the direction of the particle keep on changes. Here you see, it is a north. Here it is a west. Here it is a south. Here it is a east. Got it? So because of a change in direction, you can say that the particle is in a change in a velocity. Why I am calling it as a change? Speed is the same, means the magnitude of the particle, magnitude of a velocity, or you can say directly speed is a constant, but as it is changing a direction, if we consider a speed along with the direction, we call it as a velocity. So therefore, can I write change in a velocity? Yes. Change in a velocity. Whenever there is a change in velocity, you can call it as the acceleration of the particle. Acceleration. Here acceleration is there. So uniform circular motion, okay. Uniform circular motion. Uniform circular motion is accelerated motion. Accelerated motion. Even though speed is constant, but the velocity not. Okay. Why velocity is not constant? Because change in direction. Accelerated motion. Okay. This type of question you can expect in your schools. Got it? Now, so let's move. The force that causes acceleration, because change in direction of the particle, keeps the body moving along a circular path, is acting towards the center. So if a question asked based on a centripetal force, center seeking force, okay, centripetal force is nothing but a center seeking force. Center seeking force. Center seeking a force, okay. In your school exam, they can ask, what is the direction of a centripetal force, okay. What is the direction of centripetal force? Here, the direction acting towards the center, okay. And example for circular motion, okay. The first example you can consider, the motion of a moon around the earth is due to centripetal force. Okay, if anybody asks you, what is the reason moon is always in the circular path around the earth? The reason, center seeking force, generally we call it as a centripetal force. Okay, and one more simple example, that is a atom. If we consider a subatomic particle, okay, so center of the atom we call it as a nucleus. And in the nucleus, we can see there is a proton as well as a neutron. And the center of the nucleus of an atom is a positively charged due to proton. And electron will be revolving around the nucleus of an atom in a circular path. And again, what is the reason behind it? It is a centripetal force. Got it? And the next example, okay, first example it is done. Second example, centripetal force is provided by the force of attraction by the earth. Okay, so that centripetal force, okay, who will provide that centripetal force between earth as well as the moon? That is the centripetal force provided by the earth. Got it? Okay, right. So here you can see the examples other than earth and moon. So first example, spinning a ball on a string. So this is how the particle of or else the path of the ball looks like. It is a circular path, and this hand here, the centripetal force provided by the hands of the player, okay, or else this person acting towards the center of the circular path. That centripetal force is always acting towards the center of the circular path. And here you can see a turning of a car, okay, turning a car. Next one, you can see going through a loop of an roller coaster. And here we have one more example. So same, instead of moon and earth, here we have considered earth and sun. Okay, not only earth and sun, here you can consider any other different planets. Example for uniform circular motion. Got it? Okay. Now let's move on to the next topic. The topic is universal law of gravitation. So first you need to know what is a gravitation. Instead of universal law of a gravitation, first we need to know what is a gravitation. Okay, what is a gravitation? So here a gravitation means, okay, so gravitation means, listen careful, okay. So if I throw anything up, okay, let me consider this is a cell, okay. If I throw upward, again it is coming back. One more time. If I throw upward, it is coming back. And even these are two bodies, okay. There is a force between them, okay. Even if I consider this bottle and this pen, and there is a force between these two. Even if I consider the particles of the screen and myself, there is a force between them. Okay. So here gravitation is nothing but the force of attraction. It is always, okay, it is always attractive in nature. Okay. Universal law of gravitation, it is always attractive in nature. Okay. And the force of attraction between any two mass, okay, any two mass, we call it as a gravitation. Got it? Fine. So force of attraction between any two masses, even if we consider particle has a mass, right? Let me consider an example of electron. Electron has a mass. What is the mass of electron? That is the 9.1 into 10 power minus 31 kg. Yes, of course, it is a very small, but it has a mass. So therefore, the force is exists due to a mass. We call it as a gravitational force. Okay, the force due to mass is called a gravitational force, and the force of attraction between any two mass, we call it as a gravitation. Okay, so don't be confused between gravitation and gravitational force. Gravitational force is due to a mass, where gravitation is the force of attraction between two masses. Got it? Fine. So here I can write the force of attraction, force of attraction between the masses. Okay, between, here I'll write one of the very important term, attraction between any two masses. Any two masses is called a gravitation. Okay, so here instead of saying any two masses, here I'll consider earth and mass. Okay, earth and gravity and gravitation. Okay, so let me differentiate between gravity and gravitation. I'm talking about right now gravitation. So force of attraction between earth and any object. Okay. And what about the gravity? What about the gravity? What about the gravity? This gravity, it is also force of attraction. The force of attraction, or else you can say that force of interaction between. Okay. Force of attraction between any two masses. Any two masses. Okay, any two masses. We call it as a gravity. Got it? And if we consider gravitation, it is one reference, it is a fixed, okay? That is the earth. And another body, it can be anything. It can be pen, it can be myself, it can be, a screen, it can be a particle, it can be moon, it can be a sun, it can be, any other planet, or it can be a satellite also. But one reference mass, it is a fixed, that is the mass of the earth. Got it? So, gravitation, the force of attraction between earth and any object, and gravity means it is the force of attraction between any two masses. Okay. So, here any two masses, but here it is a fixed earth and any object. Got it? Okay. Now, next one. Gravitation, it is a fixed. Gravitation means the force of attraction between earth, one reference point, it is a fixed, and any other mass of the object. Okay. Now, statement of this universal law of gravitation. Why do we call it as the universal law of gravitation? We are talking about a force, right? We are talking about a force. That means this force is universal. Why do we call it as a universal? Because this force exists between the bodies or particle which has a mass. It can be anything. Okay. So this law is a universal law because it is applicable for any body which is having a mass. It doesn't matter about size of the body or an object. Okay, size of the body or size of the object. It doesn't matter. If it is having a mass, then there is a force exist. Clear? Now, every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the center of the objects. Okay. So let me consider this is a mass 1. Okay. This is a mass 1 and this is the mass 2. Mass 1 and a mass 2. And according to the statement, okay, universal law of gravitation. So here there is a force exists. What type of a force? It is the attractive in nature. What is that attractive in nature? For example, this mass exerting a force on mass 2. Okay. This mass 1 exerting a force on mass 2. Therefore, it is attractive in nature. Therefore, it is trying to bring this body towards it. At the same time, this mass is also exerting a force on this mass 1 and trying to move this body towards it. So this is a force that is attractive in nature. Okay. And we call this force as, gravitational force. Okay. So this is F force on a 1 due to 2, and this is a force on a 2 due to 1. Both are equal in a magnitude. Okay. Both are equal in a magnitude but opposite in direction. Okay. Both are equal in magnitude but opposite in direction. But here we are considering only magnitude of the force, that is the gravitational force. We are not talking about a direction because already we specified what is the direction of a force existing between two masses. Okay. So by this, the statement, what we can write? By the statement we can write, the force which is proportional to the product of their mass. That means a force. Okay. Generally, I am writing F is directly proportional to the product of their masses. Okay. Let me write M1 and M2. Inversely proportional to the square of the distance. Okay. Force the inversely proportional to the square of the distance. Let me consider the distance between these two masses is R. Okay. Right. This is r, 1 by r square. Fine. Now, what I have to do is combine them. Combine them, okay? Combine them. So, product of two masses inversely proportional to the square of the distance. I want to eliminate this proportional. What I can do is consider proportionality constant, that is the g. m1, m2 divided by r square. So, this formula is represented by force between two masses. Okay. And here m1 means mass of the body 1 or mass of the body particle 1. And here, yeah, mass of the body 2 or else mass of the particle 2. Okay. Or else mass of an object 1 or mass of an object 2. And the separation between them, that is the r square. Okay. Now, so this one we call it as a gravitational force. Okay. Now, what is the SI unit of this gravitational force? SI unit of this gravitational force. Okay. So that is the Newton again. Any type of a force having same unit. Okay. That is the Newton. And mass 1 and mass 2, it is in terms of a kg, or it is in terms of a, meter. SI unit. Okay. Now, here you have a one question. Sir, what is this G? What is this G? Here we are going to deal with the 2G, okay, 2 G's. First one small letter G and the second one, that is the capital letter G. So that is second, letter G, that is the capital letter G. What does it indicate? So here G indicates, okay, G indicates universal, okay, universal, okay, universal gravitational constant. Universal gravitational constant. And the value of this, okay, experimentally proved, the value of this G is 6.67 into 10 power minus 11. Okay, what is the SI unit of this G? Newton meter square per kg square. Okay. And in this particular lecture, we are going to consider, okay, this as approximately 6.7 into 10 power minus 11 Newton meter square per kg square. Okay. Clear? So statement is simple. And why do we call it as the universal gravitational constant? And this force, okay, this force is, okay, so this force is independent of a medium between the two masses m1 and m2. Okay. So what exactly this statement indicates? Okay. Let's consider there are two masses m1 and m2, and these two masses are kept in an air medium. Let's assume, okay, let's assume example, okay, let's assume example in air, okay, in air, the force of attraction between these two masses in an air medium, let's say that is the 10 Newton, okay, let's say that is the 10 Newton, and the same masses, okay. So in this case, what I have considered? So here I have considered separation, it is a 1 meter, okay, separation, it is a 1 meter. Let's consider whatever the number okay. This 10 Newton indicates my reference point. For example, I am considering. After calculation, it can be different because it depends on a mass as well as separation between them, right? So let's assume the separation is a constant and the mass of two bodies are constant. But the condition what I am considering is, first case, I have kept these two masses, okay, in a air medium. I got the force of attraction between these two masses is the 10 Newton, okay. Now, what happens in case of a liquid? In case of a liquid, okay, liquids. Let's consider in water, okay. Let's consider example water, okay. If I consider same setup, but instead of air, I have kept the same setup into the liquid medium, that is the water. Okay, same masses and the separation between them is also same. The same system I have kept in a water. Okay, then what will be the force? Your question will be, sir, will the force will be same or will be different? Answer is, it will remain same. Okay, so still the force between these two, still it is a 10 Newton only. And let's consider, okay, let's consider, yeah, two mediums are enough. Okay, one it is an air and another one it is in a liquid. What if I consider, okay, vacuum? In a vacuum, there is nothing. Okay, there is nothing means even air particles are not present. Completely empty space. Okay, completely empty space. Generally in a physics we call it as a vacuum. Nothing but space means above our earth surface. In the sky, just consider it as a sky. Okay, in a sky, above the earth surface, where there is nothing, even air particles are not present. In that particular situation also, if we consider, okay, same setup. So first case, what was the medium? That is the air medium. What was the force? The 10 Newton. The same setup we have kept in a water, that is the liquid medium. The force between two masses, still it is the 10 Newton. And the same setup, okay, when you take into the space, nothing but in a vacuum, where there is nothing, what is the force of attraction between them? Means it is still 10 Newton only. Okay, so that indicates this gravitational force between two masses, it remains same. Okay, so that is 10 Newton, 10 Newton, 10 Newton. It is the independent of a medium between two masses. Got it? Okay, now why it is the universal law? Why it is a universal law? This statement is very, very important. Okay, this statement is very, very important. The statement is simple. Okay, why we call it as a universal? The law is universal in the sense that it is applicable to all the particles, all the bodies, all the objects, irrespective of a size and shape. If a mass is there, then it is applicable. Okay, now it is applicable to all the bodies, whether the bodies are big or small, whether they are celestial or terrestrial. Okay, it is applicable between subatomic particles. It is applicable between, micro level. It is applicable between any two masses. For example, let's consider this and this, or else this and this, whatever it is, or else the force between, okay, force between earth as well as the moon, or else earth as well as sun, right? It is applicable. So that is the reason we call it as a universal law. Okay, now so let's move on to this is the mathematical formula, that is the gravitational force between two masses. Okay, now so next one, importance of this universal law of gravitation. What is the so importance about this universal law of gravitation? Okay, the first point you can notice, okay, the first point you can notice, the force that binds us the earth, okay, binds us to the earth. Okay, for example, we know that the earth is in motion around the sun in a circular orbit with a speed, lot of speed. Okay, you cannot imagine. Okay, so around 800 something miles per hour. Okay, so just imagine if the earth is moving that much speed around the sun, why can't we fly away from the surface of earth? We have to fly, right? For example, let's consider merry-go-round. Okay, merry-go-round. So if you leave the support, okay, you're sitting on some toy and it will be moving in a circular path. Okay, you'll be holding some support. If you leave that support, you'll be flying away. Like if you revolving that stone with the help of a thread, if you leave it, what happens? It will fly tangentially, right? In the same way, if you go in a merry-go-round, if there is no support, what will happen? You'll fly away. But in the same way, on the earth surface, we are not getting any support, means we are not holding any support. Still we are not flying away. We are not flying away from the surface of earth. Which one binds us to the surface of earth or else earth? That is a gravitation. That is a force exist between myself as well as the earth. Okay, so the universal law of gravitation successfully explains several phenomena which we are believed to unconnected. Initial days we are unaware of these concepts. Okay, unconnected, we thought that it is unconnected, but later on we got to know this universal gravitational law successfully explained. If we are binds to earth, that is the reason, simple, that is the universal law of gravitation. Second one, let's consider the motion of the moon around the earth. Already we have discussed, that is the centripetal force. Who will provide that centripetal force? Earth. Okay, if the moon revolving around the earth, then there should be a centripetal force, right? Who will provide that centripetal force? That is provided by earth only. The next one, motion of a planet around the sun. And here so many planets, means 8 planets, okay, around the sun, okay, moving in a circular path. So who will provide centripetal force for all these planets? The centripetal force provided by a sun, okay, and which is explained by universal law of gravitation. And the last one, the tides due to the moon and the sun. So in the sea, we can see tides, okay, so a high level and a low level, okay, so tides. What causes that tides? Okay, so reason, it is simple, that is the moon, okay, due to moon as well as the sun. That is a gravitational force. Gravitational force due to sun as well as the moon are the reason for the tides. But generally we can say that as compared to the sun, a moon is very near to our earth surface. Generally we say that the reason behind these tides, it is due to moon. Let's consider moon only. Okay, now so we got to know what is the importance of universal gravitational law. Then let's move on to the next topic. Okay, next topic, that is questioning part. Okay, so let's calculate this question. Question says, example 9.1, NCERT textbook, from the NCERT textbook. The mass of the earth is 6 into 10 power 24 kg, okay, and that of the moon is 7.4 into 10 power 22 kg. If the distance between the earth and moon is 3.84 into 10 power 5 kilometer, calculate the force exerted by the earth on the moon. Okay, that is the centripetal force, okay, exerted by the centripetal force. Okay, so now G, they have considered 6.7 into 10 power minus 11 Newton meter square per kg square. Okay, by systematic procedure, what we need to follow? Okay, so first we need to write data. Okay, first we need to write down data. And what is that given data? First one, mass of earth. Instead of m1, here I have considered mass of the earth, that is 6 into 10 power 24 kg. Fine, sir. Next one, m2, mass of the body 2, that is the 7.4 into 10 power 22 kg. That is the mass of the moon. Okay, let's consider m base m, mass of the moon, 7.4 into 10 power 22 kg. Okay, and the next one, separation between them. Okay, the distance between the earth and the moon is 3.84 into 10 power 5 kilometer. Okay, so what you need to calculate a force between, or force exerted on a moon by the earth. Okay, so F you need to calculate, and G they have given. Okay, so first data we have written. What is the next check? The checking is whether all the physical quantities are in the same system or a different system. We have to check it. Okay, now here see, mass in a kg, SI system, yes, it is there. Okay, yes, SI system, yes. Mass is measured in terms of a kilogram, right? Yes, symbolically kg. Yes, done. And what about the distance? A distance is nothing but a length. What is the SI unit of a length? That is a meter. But here you can see that is the kilometer. What you need to do? Convert that into SI unit. Okay. So here I can write this one as 3.84 into 10 power 5 kilometer. Meter, keep it as it is. What do you mean by kilo? Kilo means 10 power 3. Okay. So 10 power 3 meter. Now it is in a SI unit. Yes. So first data, then check the units, then formula. What is that formula? F is equals to G m1 m2 divided by r square. Okay. Now substitute the values. F is equals to, what is the G value? 6.7 into 10 power minus 11 into mass 1. What is that mass 1? 6 into 10 power 24 into mass 2. How much it is? 7.4 into 10 power 22 divided by, okay, divided by r square. Where is that r? That is the distance is 3.84 into, here you can see 10 power 5, 10 power 3. It is a 10 power 8. Am I right? 10 power 8. Bases are same. Powers can be added or subtracted based on their signs. Okay. Now, simplification. F is equals to, okay. So, let's consider a calculator. Yes. Say first I'll multiply our numbers. Okay. 6.7 done into 6 done, 7.4 done. Okay. So, this is 297.48, okay, into, now, so powers 24 done plus 22 done minus 11, okay, done. It is the 35, 10 power 35, okay. Now, so denominator, let's check out 3.84. It is a square, right? Therefore, into 3.84. Yes, done. It is a 14.2 decimal point is enough. 14.74 into, here 10 power 8, double of it 10 power 16. Okay. Now, so 297.48 divided by 14.74. It is a 20.18, 2 decimal point is enough, into 10 power, okay. Already it is a 10 power 35 is there, okay, 35. If I take this 10 power 16 to the numerator, what happens? Minus 16, okay, signs becomes a changes, okay, becomes change. If it is a plus, it becomes a minus. If it is a minus, it becomes a plus, okay. Now, simplification, 35 minus a 16. How much it is? 19, okay. F is equals to, okay, so 20.18 into 10 power plus 19 Newton, okay. Or we can write in this way also by scientific method. So 2.01 into 10 power 20 Newton also. Both are correct. Okay, both are correct. Okay. So this is the NCERT question. Now let's move on to the next question. The question, okay, force due to gravity. Okay. So force due to gravity, anything if we throw, okay, anything if we throw up, after some time it will come down. Okay, anything, after some time it will come down. What is the reason for that? So there we know that there must be a force. Okay, there must be a force. But what is the force? What is the magnitude of force? We have to know. Okay, so here force due to gravity means if we throw anything upward, okay, upward. If let's consider the mass of the body is a 1 kg, okay, 1 kg. If you throw upward after reaching a maximum height, okay, after reaching maximum height, what happens? That mass of the body comes to the state of rest for a fraction of a second, okay, for a fraction of a second. So then we can consider final velocity is a 0, okay. So till then we consider, and now the first case ignore, okay, when you throw upward. Now it is the maximum height, okay, now it is the maximum height. And after reaching maximum height, what happens? It becomes a state of rest for a fraction of a second and starts moving downward. Okay, start moving downward. So if it is a moving downward, what is the force acting on it? Okay, if the apple is falling, okay, apple is falling, what is the magnitude of a force? Okay, what is the magnitude of a force? Okay, what is the magnitude of a force? Yes, of course, it is the force acting on it, but due to what? Gravity. Okay, gravity means the force of attraction between two masses. One is earth, another one is apple. What is the mass? What is the force of that? Okay, so answer is 9.8 Newton. Sir, how do you know that 9.8 Newton? By calculations. Okay, how did you do those calculations? Can you show me? Those are your answers, right? I'll show you in the next slides. Okay, so right now, what is this force of a gravity? According to the law of gravitation, the earth attracts every object around it, okay, towards its center. The force with which the earth attracts the body is called the force of gravity. Okay, this is the statement you need. Okay, the force with which the earth attracts a body is called a force of gravity, and the value of a force due to gravity, okay, I'll write Fg, force due to gravity, that is equals to 9.8 Newton. Okay, so this is the precise value, approximate value for a numerical purpose, what we consider 10 Newton. Okay, 10 Newton, this is the value. Okay, so value is 9.8 Newton, precise value, right? And here, if the object is in a motion means when an object is moving towards the center of earth, if there is a force acting, okay, if there is a force acting in the direction of a force, what happens to the acceleration, or else what happens to the velocity? Let's imagine, if forget about this, okay, if the body is moving with a certain speed, okay, let's say 10 meters per second. If there is a force acting along the direction of a motion of a body, what happens to the speed of the body? Definitely it is going to change. If there is a change in a speed in a some direction, specified direction, then we can call it as a change in a velocity. Whenever there is a change in a velocity with respect to time, what we call acceleration, right? So in the same way, this apple is a falling down with a some speed, and the force of gravity is acting in the direction of a force, in the direction of a motion. That means there is a change in a velocity, then we can call it as a acceleration. If the force is acting due to gravity, then what about that acceleration? That acceleration we call it as a acceleration due to gravity. Okay, so generally, how do you define acceleration? It is the rate of change of velocity, right? How about acceleration due to gravity? The acceleration produced in this particular apple, okay, due to gravity of earth. That is the definition of acceleration due to gravity. That's all. Okay, so in the same way, acceleration due to gravity. A uniform acceleration produced in a freely falling body due to gravitational force of the earth, that is the force of gravity, is called acceleration due to gravity. And here, if the person is falling, okay, if the person is falling, then force due to gravity, that is the 9.8 Newton. Okay, and what about acceleration due to gravity? And we know that F is equals to ma. Okay, F is equals to ma, and in place of a, what we can write? F is equals to mg. What is this g? Acceleration due to gravity. Okay, so F is equals to mg. Okay, F is equals to mg. And if I consider mass of, okay, if mass of the body is 1 kg, okay, if I consider mass of the body is 1 kg, and force due to gravity is equals to acceleration due to gravity, okay, and we know that this force due to gravity, it is the 9.8, right? 9.8 meter per second square is equals to g. So therefore, here you can consider g value 9.8 meter per second square, or okay, or approximately 10 meter per second square. 10 meter per second square. What is the condition here we have considered? If mass of the body is 1 kg, means this apple, what is the mass of that apple? 1 kg if I consider. Here falling object, here person, it cannot be 1 kg, but let's assume this falling object mass is a 1 kg. Then what will be the acceleration due to gravity? Precisely, it is a 9.8 meter per second square, but approximately you can consider it as a 10 meter per second square. Okay, right. And here you have a question. Sir, what if mass of the body is the different? What if mass of the body is different? Instead of 1 kg, it can be any number, right? Do you think this G value going to change? Okay, for such question, we have an answer, that is value of acceleration due to gravity. Value of acceleration due to gravity. Okay, that is small letter g. And the capital letter G, already we know that is a 6.7 into 10 power minus 11 Newton meter square per kg, right? Now, here, according to, okay, so let's say this is the ground, okay, nothing but the earth surface. Let's consider this is earth surface, and there is a body, okay, above the ground, of mass m, okay, mass m, and mass of the earth, okay, mass of the earth, let's say capital letter M. Mass of the earth, that is a capital letter M. Okay, now there is a force of attraction. Okay, there is a force of attraction. This is F and this is also F. According to universal law of gravitation, okay, according to universal law of gravitation, here we have F is equals to G m1 m2 divided by r square. Okay, so let's consider this is the r square. Okay, this is the r square, or else we can consider this is the radius of, okay, let's consider the separation only. Okay, so let's consider this as separation only. Now, if this is the force, okay, force due to what? That is the gravity, force due to gravity. How do we calculate? Mass into acceleration due to gravity. According to Newton's second law, we write F is equals to m into a. Here F is same, that is the force due to gravity, it is acting downward, and the mass is same, acceleration due to gravity, that is a g. Am I right? So I'll replace this F as a mg. That equals to g. In place of m, let's consider mass of the earth. In place of m2, that is the mass of the body, divided by, in what about this one? Here I do not consider a separation between two masses. Instead of that, radius of the surface, radius of the earth. Why? Comparatively, okay, comparatively, separation of the, earth surface and object which is having mass m, it is very small. So instead of considering separation, here I'll consider with respect to center, we are considering, right? Center of the earth we are considering. Okay, so let's consider instead of this one, okay, instead of this one, let's consider earth surface only. Okay, earth surface, okay, earth surface, and this is the radius of earth. Okay, now, so this is the earth surface, and here you can see the separation from the center of earth, right? From the center of earth. Yes or no? Center of earth we are considering. And comparatively, the radius of earth is more than this separation between the two bodies. Means the surface of earth and mass of the body. So that is the reason we are ignore this. So center of earth we have to consider. Okay, from here to here we need to consider, not from here to here. Center of earth we have to consider. Okay, now, so here r square. Okay, this is going to be r square. Got it? Now, so finally, m get cancelled. What about the g value? G value, it is a gm divided by r square. So with respect to surface of earth, okay, with respect to surface of earth, what is the acceleration due to gravity? Okay, so let's substitute the values. Okay, so let's substitute the values. G value we got it gm divided by r square. Okay, so if G is 6.7 into 10 power minus 11 Newton meter square per kg square. Okay, and R is radius. Okay, 6,400 kilometer. Okay, or else 6.4, here 2 zeros and 6 zeros, 10 power 6 meter. Okay, and the mass of Earth, it is around, let me check, mass of Earth, we have solved one question, right? Mass of Earth is 6 into 10 power 24, okay, 6 into 10 power 24, or else here we have a data. 24, approximately 5.98 they have considered. Okay, so fine, that's okay, no problem. So here mass, here you can consider 6 into 10 power 24, right? 24 kg. And after substituting all the values in the formula, and the final answer, that is G value, that equals to 9.8 meter per second square. And here you can consider it is the independent of a mass. Okay, it is independent. It is independent of mass of the body. Mass of the body. Mass of the body. What does it indicate? So mass of the body, if I consider this water bottle, let's say it is the 1 kg. And this is just 50 gram. Okay, let's consider this is 1 kg and this is a 50 gram. What is the acceleration due to gravity on these two bodies? It remains same. Okay, irrespective of a mass, acceleration due to gravity on both the cases, or acceleration due to gravity in both the bodies, remains the same. That is a 9.8 meter per second square. If there is no air friction, okay, let's consider if there is no air friction, nothing but opposite force, there is nothing. That means if I drop these two bodies, okay, if I drop these two bodies, one is a 50 gram, another one is a 1 kg, both the bodies will reach the ground in the same time. Okay, and if I consider one stone and another is a feather, okay, if I drop both at the same time at the same level, both the substance, one is the stone, another one is the feather, will reach the ground at the same time, because it is independent of a mass of the body. We know that feather is lighter and the stone is heavier comparatively. Okay, if there is no air friction, both the bodies reach the ground same time in a same, nothing but a same. If we drop those two bodies from the same height, that is also condition. Okay, both will reach in the same time. Got it? So this is all about acceleration due to gravity, force due to gravity, and now free fall. Okay, so free fall. What do you mean by free fall? Okay, this concept is very important for your upcoming classes, means class 11th and class 12th. Okay, so here you can see one situation where one student standing on the top of the hill. Okay, let's consider top of the hill, and he is just dropping, means just leaving the object. Dropping, leaving, is not throwing. Okay, he is not throwing an object, just he is dropping or leaving the object. So leaving or dropping case, what happens to the initial velocity? Initial velocity in this particular case becomes a 0. Okay, initial velocity becomes a 0. Okay, what is the free fall? Let's try to understand. Okay, the falling of a body from a height towards the earth only under gravitational force of earth. Okay, with no other forces acting on it. Means let's consider there is no force acting opposite of the fall of the body. Okay, then we can call it as a free fall. But in reality, there is a force acting upward, that is a air, force due to air, that we generally call it as a air friction. Okay, so then it is not a free fall. Okay, so free fall means then there must be no forces acting on it apart from gravitational force. Then we can call it as a free fall. Okay, so the falling of an object, or else the falling of a body from a height towards the earth only under the gravitational force of earth with no other forces acting on it, is called free fall. Such body is called a freely falling body. Okay, for a freely falling body, u becomes a 0. Okay, u becomes a 0. That's all. This condition is very, very important. Freely falling body, what is the velocity? It is a 0, because you are not throwing. Just before leaving, okay, just before leaving, what is the velocity? It is at rest, right? It is at rest means initial velocity is 0. If you're throwing means there must be a velocity. But here you are just dropping a body. That means initial velocity is 0. Okay, now let's move on to the next concept, that is motion of objects under the influence of a gravitational force of the earth. Okay, now here we have some equations of motion that we have learned in the last chapter. Okay, last chapter. Okay, that is a motion and force and loss of motion. We had some equations. That equations we call it as a equations of motions. There are 3 equations of motion. Okay, the first one if we consider, v is equals to u plus at. The second one, s is equals to ut plus of at square, and the third equation of motion, v square, that is equals to u square plus 2as. Okay, and the meaning of the symbols here we are using, v means a final velocity, u means initial velocity, and a means acceleration of the body, and t is the time taken by the body in a journey. Okay, and what about s? S means it is the displacement of the body. Okay, got it? Now, with respect to free fall, okay, with respect to freely falling body, what is u? That is equals to 0. And here you need to consider, here one body is dropping, okay, one body is dropping, okay, from this point. One body is dropping. Is it visible? Yes, dropping. So in this particular situation, here you can write u is 0, and this is the g value, acceleration due to gravity. Acceleration is produced, okay, acceleration is produced in this ball, so that we can see in an equal interval of time the distance is covering is unequal. That means there is a non-uniform motion. Whenever there is a non-uniform motion, definitely there is a change in velocity. Whenever there is a change in velocity, we can call it as the acceleration. But due to what? That is due to gravity. So that acceleration is due to gravity. Therefore, simply we can call it as a acceleration due to gravity. Okay. Now, so motion as well as the force due to gravity in the same direction. Therefore, in a downward direction, okay. So here very important point, in a downward direction, in downward direction, okay, a becomes positive g, and in upward direction, a becomes a minus a g. What is the reason? The force due to gravity acting downward, and if the vertically moving object, okay, if the object is moving vertically, motion as well as a force, or else you can say velocity as well as acceleration due to gravity are opposite, therefore a negative sign. If velocity and acceleration, if they are in a same direction, you can consider a positive. Example here, the motion of the particle and acceleration due to gravity, this is a motion, that is nothing but a velocity. Okay, this is the velocity, and acceleration both are in a same direction, therefore g is a positive. What if g is always vertically downward? Because that is due to gravity. What is the direction of acceleration due to gravity? It is vertically downward. What if the object is moving up? In this particular case, object is moving up in this particular case, and here you can see acceleration due to gravity, it is moving downward. Both are opposite, therefore here g, that means a becomes, okay, a becomes a minus a g, and in this case a becomes a plus a g. That's all. Motion of the body and acceleration due to gravity, if they are in the same direction, g value positive. Okay, and if a motion of the body and acceleration due to gravity opposite, means that is a negative. Here I have written. Okay, now compare the equations. Okay, and for a free fall, here we have considered u is equals to 0. Right, first equation of motion. So v is equals to u plus, okay, u plus, and what happens to the first equation? U 0, right? U is 0 according to the condition. A means It is a downward motion, therefore a gt. Therefore, I can write v is equals to gt. Okay, right. First equation done. Comparing, okay. Now, second equation. Second equation. Yes, but here instead of s, we are considering height of the body. Okay, height of the body from here to here. Okay, height of the body we are covering with a h. With a h. Okay, height of the body. Now, h is equals to, okay, h is equals to 0 into t plus of, as it is, a. In place of a, the motion is downward, therefore plus g into d square, t square. Okay, 0 into t, it is still 0 of gt square. Okay, height, that is of gt square. Fine. Second equation of motion is also done. Okay, second equation of motion is also done. And the final one, okay, so final one, that is a v square plus a 0 square plus a 2 plus a g into s. In place of s, that is a h. Okay, so v square, that is equals to 2gh. Clear? Okay, so these three equations are very, very important. Okay, they can, in your school, they can ask for your unit test, midterm, preparatory, okay, and the final exam also. So this is how you can rewrite motion of an object under the influence of a gravitational force of the earth. Got it? Okay, now let's move on to the next concept. Question. A car falls off a edge. Okay, it is a edge. Okay, edge, and it drops to the ground in a 0.5 second. Okay, 0.5 second. Let g is equals to 10 meter per second square. For simplifying the calculation, sir, why we have considered 10 meter per second square? Actually, g value is 9.8 meter per second square. But why we have considered 10 meter per second square? The reason for a simplifying calculations. Okay, simplifying calculations. Okay, the first one. Okay, so first to write down data. So according to the data, so what is the data they have given? Time. How much it is? 0.5 seconds. And the g value 10 meter per second square. Okay, both are in SI unit. Fine. And here one more data they have given in terms of a wordings. Okay, in terms of a word, that is a false. Okay, false means initial velocity is 0. Okay, initial velocity is 0. Fine. The first question. What is its speed on striking the ground? Okay, so on striking the ground means which equation of motion we have to use? Here we have a total 3 equations of motion, right? V is equals to u plus et, and the second one s is equals to ut plus half et square. Okay, and the next one, last one, v square is equals to u square plus 2gh, or else directly you can write v square is equals to u square plus 2as. And here we need to calculate its speed on striking the ground. Final velocity you need to calculate. Okay, and if you want to calculate a final velocity, here we have a 2 equations. Okay, 2 equations. What are those? So first one, v is equals to gt from the previous equation, and second one, v square is equals to 2gh. Okay, from these equations. Which equation of motion you have to use? gt and 2gh. Which equation? So in the data, if you see properly, there is no information of a height, right? Therefore, you have to go with this formula, the first formula. Okay, so therefore here the first one. Okay, so v is equals to gt. So after substituting the values, g is a 10 and a time, that is a 0.5 second. Okay, so v is equals to 5 meter per second. So this is the velocity of a car which is striking the ground. Okay, the next one, second, this is the velocity. Yeah, second one, what is its average speed? average speed during the time that is 0.5 seconds. Okay, average speed means, what is the formula for that? Average speed. Okay, here I'll write v average speed. Here I can write initial velocity plus final velocity divided by 2. This is the average velocity that we have learned in the motion in a straight line. Okay, and substituting the values. Okay, substituting the values, v average, that equals to initial velocity. How much it is? Initial velocity is 0. Yes, and final velocity, it is a 5 divided by 2, and v equals to 5 divided by 2. So finally you can write, okay, v average, right? This is the v average, not v. It is v average, that is 5 by 2. And v average, that equals to 2.5 meter per second. So this is the average velocity, okay, of the car. Now, last one, how high is the ledge? Okay, ledge, it is the correct only. Okay, this is correct only. Ledge means height of the car which is the falling. And how high is the ledge from the ground? Third point, that is the third sub question. Height, here you need to find out which equation of motion you have to use. Okay, so here we have here we cannot see h value. Here you can see h value. Here also you can see h value. Any one of the two equation you can use. Okay, I am using this one. Okay, that is h is equals to half gt square. Okay, so h is equals to half gt square. Fine. Substituting the values, of into g value, it is the 10, and the time is 0.5 into 0.5. Okay, so here to eliminate this, what I have considered is 10 into 0.5, that is a 5 into 0.5 divided by 2. Okay, now here to eliminate this 0.5, what I'll do, multiply and divide by 10. Okay, multiplied and divide by 10. Now finally h is equals to, and here you can see 5 into 5 divided by 2 into 10, that is a 20, and 25 divided by 20, and 5 5 is a 25, and 5 4 is a 20. So 5 by 4. Okay, so 5 by 4 means it is approximately 1.25 meter height. The height of the ledge is 1.25 meter. Okay, that is a 5 by 4 value, 1.25 meter. Okay, got it? Now let's move on to the next question. Next question. An object is a thrown, not a fall. Okay, it is a thrown. It is a thrown vertically up, and raises to the height 10 meter. Calculate the velocity with which the object was thrown upward and the time taken by the object to reach the highest point. Okay, so let's try to understand the given question with a diagram. Okay, so this is the ground. This is the ground, and from the ground, okay, object is projected. Object is projected. Okay, object is projected. Fine, object is projected with a initial velocity u. Okay, initial velocity u, but you don't know what is the initial velocity. And what happens, it will travel some height at a maximum height. Okay, top point. Okay, top point. What happens to the velocity? It comes to the rest. That means the final velocity is 0. Okay, now vertically upward. Okay, vertical upward. So acceleration due to gravity, it is always acting downward, right? Acceleration due to gravity always act downward. Now you see, velocity or motion of the object, acceleration due to gravity, opposite in direction. Therefore, what happens to the g value? That is a minus g. Okay, therefore from the diagram you can notice you have a v value, you don't have a u value, but you have a v value and a value. Okay, and a g value you can consider it as a 9.8 meter per second square. It is a known parameter, right? Now first question, what they've asked, the velocity with which object was thrown, this one. So here you can see it is a independent of a time, right? It is a independent of a time, and also if you see the data clearly from this point to this point, okay, from this point to this point, height, okay, that is a 10 meter. 10 meter, that is a height, okay. Now you have height, but it is just independent of time. Which equation of motion you have to use, okay? Which equation of motion you have to use? In entire data, it is independent of time. Therefore, you have to use third equation of motion, okay? Third equation of motion. Third equation of motion, that is v square is equals to u square plus 2as, okay? Now, substituting the values, okay? Substituting the values. V value at a top point, what is the value? That is a 0 whole square, and you don't know u, therefore u square as it is, plus 2. And what is the value of a? It is a is a negative g, and in place of s, that is a h only, okay. So it is a 0 square, it is a 0 only, u square plus into minus 2 into 9.8 into height is a 10, okay. And what I'll do, I'll rearrange this equation. What I will get, u square, that is equals to, and 2 into 98, okay, 2 into 98, 2 into 98. Let's calculate this one. 98 into 2, 196, okay. U square is equals to 196, okay. And if I want u, I have to take under square root 196, okay. Now, u is equals to, this is 196. Let's check out for under square root of 16, okay. So, 96 and 6 and 1, okay. 6 and this is 6 and 1, and this is 50, and this is 256. That means the 16 is not possible, okay. 16 is not possible, okay. So let's check out one more time. Okay, directly we can use calculator. So first 2 into 9.8 into 10, 196 under square root 14, okay. So the value is 14 meter per second, okay. So the value of initial velocity 14 meter per second, okay. The first sub question, it is a clear. Now, second point, what they're asking, the time taken by the object to reach the highest point. This is the highest point or top point, okay. So here, which type of equation of motion we have to use? The first equation of motion, okay. First equation of motion, and this one also you can use, no problem. Wherever there is t, you can use, okay. So by the data, you can use this one or you can use this one, whatever you want, you can use this, okay. So here, of second equation of motion you have to use. Why not this? Final velocity becomes 0, so t becomes a 0, okay. So maximum height we are going to calculate, okay. Initial velocity we have, okay, fine. Yes. By the data, you don't know initial velocity, okay. Initial velocity, okay, already we calculated, right? So by that also we can calculate. So what is the value of h is equals to of gt square, okay, gt square. So after rearranging this, okay, 2h divided by g. So what is the value? 2 into 10 divided by 9.8. So that is a 20 divided by 9.8. Okay. So 20 divided by 9.8, that is 2 t square is equals to 2.04. Okay, this is enough. And t is under square root to 2.04. Here plus or minus signs will come, but let's consider a positive only, okay, because the time cannot be negative. And the time is, t is 1.42 seconds, okay. This is the required solution, okay, fine. Only 2 sub questions. Let's move on to the next question. Mass. What is this mass? What is this mass? Here we have, I guess, mass as well as, mass. After that, here we have a weight of the body also, okay, weight of the body. So first, try to understand what is a mass. Mass is the property of a body. Okay, it do not change. Why? Because if we consider any substance, okay, any substance, it is made up of a matter. So if we consider a body or object, the amount of matter contained by the object is called matter. So that matter, if you place on the surface of earth, if you place on the surface of moon, if you place anywhere, the amount of matter contained by the body remains the same. Okay. So mass is nothing but it is the amount of matter contained by the body. Okay. So that is the mass. Okay. Right. The amount of matter contained by the object or body is called mass of the object. And in the second chapter, force and laws of motion, when we are talking about inertia, what is the measure of inertia? Mass is the measure of inertia. We have discussed about it. Okay. So mass of the object is the measure of its inertia. Okay, mass of the object is a measure of its inertia. Fine. Second one, how do you measure a mass? By using beam balance or a physical balance. Okay. And what is the unit of a mass? Already you know that. That is a kilogram, right? So SI unit is a kilogram. SI unit is a kilogram. And symbolically we can represent as a small letter kg. And quantity, whether it is a scalar quantity or vector quantity, it is a scalar only, because we are not talking about any direction of the body. Just we are talking about the amount of matter contained by the body. Okay, so amount of matter contained by the body, let's consider this is the one body and this is the second body. Okay, so amount of matter contained by the body, if I take these two bodies and keep on the beam balance, okay, based on amount of matter of the body contained by these two, okay, amount of the matter contained by this and this, okay, it will show by reading. Okay, so that beam balance or physical balance. So by appearance you can notice this, the amount of matter contained by this body is more compared to this. I hope you know that what is matter in chemistry. I hope you have already learned about what is matter. Okay, matter is nothing but something which is occupied by space and has a mass and perceived by our senses. Okay, so this nothing but matter only. But how to define a mass? Mass is nothing but amount of a matter contained by the body. That's all. Okay, right. Next one, measuring device. Measuring device, you can consider a beam balance. Okay, that one, beam balance, or physical balance, physical balance. Okay, and here our question is, mass of the object is constant or variable? Variable means it changes. Do you think the mass of the body changes? Yes. Okay, but here under certain conditions. Okay, under certain conditions. What are those? If the speed of the object is less than speed of light, what is the speed of light? Here, if it is the speed, okay, here I am considering less than speed of light. Here condition I am applying. If less than speed of light, that is c is equals to, that is c indicates speed of light. Okay, 3 lakhs kilometer per second. Okay, 3 into 10 power 8 meter per second. If it is less than the speed, the mass of a body constant, do not change. Okay, here you can say mass of the body is constant. Mass of the body is constant. Okay, if you take any body which is having a mass, it will remain same. Okay, for example, let's say mass of this object. Okay, mass of this object, say it is the 1 kg on the surface of earth, and this mass of the body taken into the surface of a moon, still its mass remains same, because it's just amount of matter contained by the body. Or any other planet or any other satellite or any place in the universe, the mass of this object remains same. Okay, and here condition is if the speed of the body is less than speed of light, or else you can say in simple word, okay, constant at rest. Okay, constant at rest, constant at rest. Okay, constant at rest. And what about, sir, what if the speed of the body is moving with a more than speed of light? It is not possible. If so, the mass of the body going to be changed under relativistic mechanics. Okay, so that is given by m naught divided by under square root 1 minus v square divided by c square. Now add this position in the 9th class, it is not required. At rest, yes, mass of the object is a constant. It is not going to change. Maybe it is on the surface of earth, maybe it is on the surface of moon, or anywhere in the universe. Got it? Okay, this is the condition at rest. Now let's move on to the next concept, that is the weight. Okay, that is the weight. What is this weight? If there is a mass of the body, okay, on the surface of earth, okay, if I leave it, what happens? It will come down. What is the reason behind it? That is the force due to gravity, that's all. And this force acting on the mass of the body, it is given by mass into acceleration due to gravity. Okay, so by the concept, okay, according to Newton's second law, what do we say? F is directly proportional to the m into a. Here mass, let's consider mass is a constant. Okay, mass is constant. Or else here in place of acceleration, here we are considering acceleration due to gravity. So if there is a mass, okay, on the surface of earth, if there is a mass on the surface of earth, there is a force acting on the body. It is always vertically downward. So that we call it as the weight of the body. And this weight of the body is nothing but, the force by which earth attracts towards the center of earth. Okay, it is simple. Okay, weight is nothing but a force, okay, with which the force of a gravity or else force due to earth is attracted towards the earth surface. That's all. Okay, and the force it is the given by, okay, force it is given by m into g. Simple. Okay, m into g. Clear? The same formula. This is a mass. Got it? Now, so according to the definition, let's read out once. The weight of an object is the force with which it is attracted towards the earth. That we call it as the weight of the body. And this weight of the body depends on acceleration due to gravity. And acceleration due to gravity depends on mass of the planet and radius of the planet. For example, here on the surface of earth, the g value is 9.8 meter per second square. What is the reason? G is a constant, that is a capital letter G is a constant, and mass of the earth and radius of earth are dependable parameters. Okay, if m as well as r changes, what happens to the small letter g? That is also changes. Getting my point? Okay, and here I want to say this, okay, capital letter G, it is a constant, okay, it is a constant. What is the value of this? That is a 6.7 into 10 power minus 11 Newton meter square per kg square. Okay, it is remains same wherever it is. Okay, wherever it is, maybe on the surface of earth, maybe on the surface of moon, maybe on other planet, anywhere in the universe. But second one, okay, second one, this small letter g, that is not a constant. Okay, it is a variable. It is a variable. It is a variable. Okay, why? Because this g depends on gm divided by r. This m indicates mass of the planet. Okay, here I have considered, okay, if I consider acceleration due to gravity on earth, that means this g is a constant and mass of the earth divided by radius of earth. Okay, what if I consider a moon? Acceleration due to gravity on the moon surface, g is a constant, and here mass of the moon divided by, okay, mass of the moon divided by radius of the moon. Okay, so as mass as well as radius changes, this g value is also going to be changed. Getting a point? On the surface of earth, that is 9.8 meter per second square. But the same acceleration due to gravity, if I consider on the surface of a moon, that will be different because it is depends on mass of the planet or mass of the location and radius of that location. Getting my point? Okay, simple. Now, next one. Next one. So definition is clear. Weight is nothing but a force only. Okay, weight is nothing but a force only. Weight is nothing but a force. Okay, due to gravity. Okay, of the planet. Okay. Now, SI unit. If it is a force, what is the SI unit of a force? That is the Newton, and it represented by capital letter N. And the quantity, it is the vector quantity because it is always acting towards the center of Earth or center of the planet. As we are talking about Earth, here I am talking about a center of Earth. Okay, vector quantity because it is always directed towards the center of Earth. See, direction towards the center of Earth. Now, measuring device, weight is measured by, okay, weighing machine or else spring balance. Okay, force is measured by, okay, force is measured by spring balance. Okay, spring balance, this is the spring balance. Okay, spring balance, this is a weighing machine, this is weight is measured by a weighing machine, but this weighing machine is works based on a principle. Okay, spring balance only. Okay, weighing machine works based on a principle, spring balance only. Therefore, directly you can say this weight of the body is also measured using a spring balance. Okay, if you don't remember in your examination, all just write down it is a weighing machine. That's all. Okay, because weighing machine works based on the principle, that is the spring balance. Got it? Now, device, spring balance. Or weighing machine. Okay, done. Next one, relation between the mass and weight of the body. Already we have derived. That is weight of the body, that is equals to mass. Here I'll write weight of the body. Weight of the body that equals to mass of the body and acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity. Here we can consider W is equals to mass into acceleration due to gravity. That is mg. Okay. I hope it is clear for everybody. Now, next one, that is the weight of an object on the moon. Here we have, two situations, means two locations. One is Earth and another one is a moon. And here we need to calculate what is the weight on a surface of Earth and what is the weight on surface of a moon of the body. Okay. So let's consider here just we need to find out, weight, ratio of the weights. Okay. Ratio of the weights. Ratio of the weights. Okay. Now, so let's consider this is the first case. Yes, same body, and this is let's consider this is Earth surface. And this is the moon surface. Okay. Now, this is Earth. It is not visible. Earth surface, and this is a moon. Okay. Now, so this is mass of the body, and this is also mass of the body, and we know that force is always acting towards the center of the planet. Here I have considered Earth, and here I have considered Moon. Okay, now, so here we need to calculate the ratio of weight. Okay, so therefore here what I can write, weight of the body on Earth surface, that is the WE, that equals to mass of the body. Okay, mass of the body, or else you can write weight of the body is nothing but a force that is on Earth, and here weight of the body on a moon, that is nothing but a force on a moon. Okay, now consider a force, universal gravitational law. According to universal gravitational law, this F is equals to F generally. Okay, F is equals to G m1 m2 divided by r square. Okay, so here I'll consider, so WE, that is the weight on the surface, is equals to, substitute the same formula, that is the G m1 means here mass of the earth I'll consider, mass of the earth into mass of the body divided by radius of earth square. Okay, in this case weight of the body on the moon, that is equals to G is a constant, mass of the moon, mass of the body divided by radius of the moon square. Okay, now take the ratio WE divided by WM, that is G mass of the earth, mass of the body. Okay, I'll write a B, and here also B, mass of the body as a B, MB. Okay, and divided by radius of earth square. Okay, into weight of the body, weight of the body on the moon surface, that is G mass of the moon, mass of the body, and radius of the moon square. Okay, now here you can see G and G get cancelled, and mass of the body and mass of the body get cancelled, and remaining you can see mass of the earth into radius of the moon square divided by mass of the moon divided by into radius of earth square. Okay, clear? Now what do you have to do? So weight of the body on a surface of earth divided by weight of the body on surface of a moon, that equals to, so mass, compare that, ME divided by MM, ME divided by MM, grouping, mass with mass and radius with the radius. Okay, and RM divided by RE, RM divided by RE whole square. Now substitute the values. WE divided by WM, mass of earth, how much it is? Here 5.98 into 10 power 24. 5.98 into 10 power 24 kg divided by this one, mass of the moon, that is 7.36. 7.36 into 10 power 22, I guess. Let me cross check. Yes, 22 only. And radius of earth. Okay, so radius of earth, that is 6.37 into 10 power 6. 6.37 into 10 power 6 divided by radius of the moon, that is 1.74. 1.74 into 10 power 6 whole square. Okay, and here you can see, so 10 power 24 and 10 power 22, here 2 remaining, and 10 power 6, 10 power 6 cancelled out. So WE divided by WM, that equals to, take the calculator for easy calculations. See, 5.98 divided by 7.36. 5.98 divided by 7.36. That is, 0.8125 into 10 power 2 is left out, therefore 100 into 100. So that is 81.25. Okay, into this one. So 6.37 divided by 1.74. Okay, so this is the value. So that is a 3.66 whole square. Okay, so now ratio we have to calculate, right? Okay. Fine, that's fine. So here you can write 3.6 into 3.66. 3.66 into 3.66 into 81.25. That is 1088. 1088. Okay. 1088. 39. Okay. Or else you can further simplify this one as 5.6. This is 5.98 as 6 and 7.36 as a 7.35. Okay. So this is one way of writing. Okay. Weight of Earth, that is 1088.39 times of weight of the body on a moon. This is one way. Okay. This is one way. Or else, so consider from here only. Okay. Consider from here only. Okay. So weight of the Earth. Okay. Weight of the Earth and weight of the moon. Okay. And here we have another way, that is W is equals to mg. Okay. Mg. So here you can write that as, okay, weight of the g value. Okay. So here mg E divided by W is equals to mg m. Okay. M get cancelled. So here g, mass of the Earth, divided by r square E, and here g m moon divided by rm square. Okay. And again simplification, this is OR. Okay. OR method, and m that equals to, okay, now. So g get cancelled, mass of the Earth divided by radius E square, okay, re square, into rm square divided by mass of the moon. Okay. So after simplification, okay, after substituting the values and everything, okay, you will be getting 1 by 6. 1 by 6 Wm. Got it? Okay, clear? That indicates acceleration due to gravity on a moon, that is equals to 1 by 6 times of acceleration due to gravity of body on a Earth, or else directly gm is equals to ge divided by 6. Okay. So these are simple calculations. Aram se can do it. Okay. And here also you can write this one as, okay, so this one as, so we divided by reciprocal also you can write. So this becomes 1 by 6 or else we divided by 6. Okay. Now let's move on to the next concept, that is question 9.4. Mass of an object is the 10 kg. What is its weight on a Earth? Simple question. Okay. So data, if you write a data, okay. So here mass, that is a 10 kg, and on Earth they have asked, that is we, and we know that we, that is equals to gm or mg, right? Mg, that is acceleration due to gravity on Earth. So we is equals to mass, that is a 10 kg, into this is the 9.8, right? So W is equals to 98 Newton. 98 Newton. Got it? Simple calculations. Nothing to worry. Got it? Now, next one. An object weighs 10 Newton when measured on the surface of Earth. What would be its weight when measured on the surface of the moon? Already we got to know. First write down the data, then we'll proceed how to solve this. Approach. Okay. What is the approach of solving this question? So first they have given object weight on the surface of Earth, that is weight of the Earth, weight of the body on Earth's surface, that is 10 Newton. Okay. And what would be its weight when measured on the surface of the moon? Weight of the body on the moon surface, question mark. So by the data, you can conclude that, okay, WE is equals to, okay, and mg, okay, and WE value we know that that is the 10, is equals to mass. How much it is? Mass we have to calculate, and G, that is the 9.8, okay. M value that is given by 10 divided by 9.8 kg, okay, right? This is the mass of the body. Now, here we need to calculate weight of the body on a moon surface, okay. And here you can write a mass of the body into acceleration due to gravity on moon surface. And we know that acceleration due to gravity on moon surface, that is 1/6 time of acceleration due to gravity on surface of Earth. Substitute the values, okay. So Wm that is equals to m value that is 10.98, okay, and gm value we know that that is a 1.1/6 into ge, okay, ge, and we know that acceleration due to gravity on Earth's surface 10 divided by 9.8 into 1/6 into 9.8, okay. So here 9.8 get cancelled. So WE that is equals to, sorry, this is a WM, not a E. Weight of the body on the moon. So 10/6. So for 10/6, what will be the answer? 10/6. That is 1.66 Newton. Okay. Simple. Okay. There is one more method, okay. Arams you can solve it. How, sir? One more method. Method 2. Method 2. Direct method, okay. Method 2. So weight of the body on a moon surface, that is equals to mass of the body, okay, into acceleration due to gravity on a moon surface, okay. Now, so here they have given this one, 10, okay. And we know that weight of a body on a moon surface, that is equals to weight of the body on a earth surface divided by 6. That's all, okay. So moon, that is equals to, so weight of the body on a moon surface, earth, that is 10 divided by 6, that is 1.66 Newton. 2 steps only 2 steps. Okay, when you know the relations, aram se you can do it, okay. When you know the relations, aram se you can do it, okay. No problem. Fine. Next one. That is a thrust. Thrust to topic. So like a weight is the type of a force, okay. Weight is nothing but a force by which, okay, which attracts towards the center of earth. Nothing but we can say that a force is nothing but a force only. Thrust is also force. But what kind of force? That we need to know, okay. Force is a vector quantity. It can be applied in any direction, right? Any direction on the surface, okay. So let me consider this is the surface of earth, okay, or else any surface, okay. So I can apply a force in this way with respect to normal, okay, and this way, right, or else this way, okay, or else this way, or else, you know, this way, alright, this way, and this way also, okay. So here you see all these are forces, okay. This is also force, this is also force, this is also force, this is also force, and this is also force. With respect to normal, okay. Normal means perpendicular to the surface. Perpendicular to the surface, okay. Perpendicular to the surface. Perpendicular to the surface from point of contact. Point of a contact. This is also a normal, okay. Now, here I'll give the name. This is a 1, and this is a 2, and this is a 3, and this is a 4, and this is a 5. Out of 5, okay, all these 5 are forces only. But in 5 cases, there are 2 forces are a thrust. Thrust means a force acting on a surface normally or else perpendicular to the surface, okay. Perpendicular means, for example, if we consider this one, here there is an angle theta, but here the angle is 90 degree. Here angle is 90 degree. Here there is an angle theta and here there is an angle theta. Means 1 and 4 and 5 are forces. Forces with angle theta, and 2 and 3 forces with angle 90 degree or normal or perpendicular, okay. All the terms are same, perpendicular, okay. So this 2 and 3 cases only, we are calling it as a thrust. We are calling it as a thrust. Nothing but when a force acting on a surface normally or else perpendicular to the surface or else with the angle 90 degree with respect to the surface. So those forces only we are calling it as a thrust, okay. Thrust is nothing but, again I am telling you, it is the type of force, okay, right. So we got to know what is the thrust, okay. Thrust is a normal force which is acting on the surface. Already we have seen the examples. Now SI unit, as a thrust is the unit, thrust is the force, type of a force means, what is the SI unit? It is a Newton, okay. And the quantity, it is a vector quantity because it has a direction also, because normal to the surface, okay. Now next one, a pressure. Pressure means it is the ratio of a thrust and area, or as you can call it as a, thrust per unit area, we call it as a pressure, okay. Simple. Now in this particular case, okay, in this particular case, let me consider this is the surface and here there is a force acting, okay. There is a force acting with a 90 degree. So this is the thrust. Yes, of course, this is the thrust. And what is this? This is the area. This is the area. One more example. Let's consider this is the surface, okay, and this is the force. This is the force, okay. This is the force. This is the force acting on the surface, okay. This is the force acting on the surface. But what is the area? This much. So this is the area, okay, area, and this is the force acting on the surface. This is the force acting on the surface. So this is the force, okay. So that is nothing but a thrust. With respect to surface, it is a 90 degree only. So the thrust per unit area, we call it as a pressure, okay. Thrust per unit area, we call it as a pressure. Got it? Now thrust per unit area, we call it as a pressure. Simple. Now formula wise, pressure that is equals to thrust per unit area. So generally, okay, generally in textbook they'll give you F divided by A. But actually it is the thrust per unit area, not just a force per unit area. Force per unit area, it is not the right answer, but precisely, okay, that is generally correct, but precisely pressure is nothing but a thrust per unit area. Got it? Now next one, SI unit. If you look at the formula, unit of a pressure that is equals to Newton per meter square. What is the unit of area? That is a meter square. So here this Newton per meter square only we call it as a Pascal. We call it as a Pascal. So represented by PA. So here also say Pascal, or okay, I'll write a full words only. Pascal, that is given by PA, or 1 Pascal that equals to 1 Newton per meter square. Okay, both are correct. Clear? And quantity, it is a scalar only. Okay, and a measuring device, barometer. Barometer. This one is a barometer. Okay, got it? Now, next one. Questioning part 9.6. A block of wood is kept on a tabletop. The mass of wooden block is a 5 kg. Mass they have given. Okay, 5 kg mass. And its dimensions are 40 centimeter into 20 centimeter into 10 centimeter. Nothing but they are talking about length into breadth into height. Okay, so length into breadth into height. Nothing but they have given a volume. Find the pressure. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of a dimensions. Here we have two situations where area is a different. Okay, the body is same but the area is a different. Okay, now, so first one, data we need to calculate. I mean, first we need to write down data. Data. Okay, done. Data, it is completed. So they have given volume, that is 40 centimeter, okay, 20 centimeter, okay, 10 centimeter, fine. Find the pressure. Pressure we need to calculate, okay. So here we have two situations. For area, first case, that is the 20 centimeter into 10 centimeter. And the second case, area, because length into breadth, nothing but area only, right? So area is nothing but length into breadth. Okay, but they have given here length, this is the breadth, and this is the length, and this is the breadth. Okay, next case, that is the 40 centimeter into 20 centimeter. Okay, fine. So here pressure. So pressure means, pressure is nothing but a thrust or else a force, perpendicular force divided by area. So force is given by, okay, force is given by mg, nothing but weight of the body. Force is nothing but, here we are talking about a weight divided by area, and weight, it is given by mg divided by area. Okay, area of cross section, I mean area of the block which is covered or occupied. Now, so let me consider first case. Okay, so first let me consider weight of the body, mass, that is a 5 kg into g value, that is a 9.8. Okay, 9.8, acceleration due to gravity 9.8. So W is equals to, okay, so W is equals to 5 into 9.8, 49. 49 Newton. That is nothing but a force. I'm considering force. Okay, right. So here we need to calculate, area for this. Okay, so first case, right? So now, area, that is given by 20 centimeter. Centimeter means first we need to consider into meter. Centimeter to meter. That is nothing but 20, 10 power minus 2 meter into 10 into 10 power minus 2 meter. Okay. Now, so already we know that pressure, it is given by force divided by area. Substitute the values. Pressure, that is equals to 49 Newton divided by area. Area, how much it is? 20. See, first I'll substitute the values. Here I have done this one. So here, so 20 into 10, that is the 200. So 200 into 10 power minus 4. Okay. So let me write 200 into 10 power minus 4. Fine. So pressure is equals to 49. Okay, 49 divided by, this one can be written as 10 power 2 because this two zeros can be written as a 10 power plus 2 into 10 power minus 4. Okay, so 49 divided by 49 divided by 2, that is 24. Okay, so 49 divided by 2, it is nothing but 24.5 into 10 power 2. Okay, 10 power 2. So finally you can write pressure that equals to 2450 Pascal or 2450 Newton per meter square. Okay. So if you have any question in this step, so what happens? 10 power 2, 10 power minus 2. What happens here? Here, let me write this one. Pressure is equals to 49 divided by 2 into 10 power minus 2. Okay. If I shift that into numerator, it becomes a positive. Okay. Plus 2. Got it? Now, second case we have to solve. So second case, that is given by pressure is equals to 49 divided by area. So first let me write area only. So area, second case, area, that is 40 20. So 40 into 20, 40 centimeter into 20 centimeter. It is in a CGS unit. Let me consider into SI unit. So 10 power minus 2 meter into 20 into 10 power minus 2 meter. Okay. So area. So 40 into 20, 40 into 20, that is 800 into 10 power minus 4 meter square. Okay. And after simplifying this, this can be written as 10 power 2, 8 into 10 power 2 into 10 power minus 4 meter square. So finally you can write A is equals to, area is equals to 10 power minus 2 meter square. Now pressure. So pressure is equals to, force. Already we got it. 49 divided by area, that is 8 into 10 power minus 2. Okay. So 49 divided by, so 8, that is 6.125 into 10 power plus 2. Because when you shift this 10 power minus 2 from denominator to numerator, it becomes a positive. Okay. So after simplifying this into 100, this becomes pressure that is equals to 612.5 Pascal or 612.5 Newton per meter square. Okay. So that's all. Two cases they have asked. Two cases we have solved this one. Okay. Now, let's move on to the next concept, that is the pressure in a fluids. Okay. So first case, okay, pressure in a solids. Why there is a pressure in a solids at a contact? Okay. So where does the pressure exerts in a solids? The pressure will be exerted between the contact between two surfaces. Okay. That is due to weight of the body. Okay. A simple statement, okay, regarding solids. The pressure due to solids is due to weight of the solids or else the body. Now in the same way, the pressure in a fluids, that is also due to weight of the fluids. So first question, sir, what do you mean by fluids? Fluids means the substance which can flow. The substance which can flow. Example, so, liquids and gases. Okay, liquids, let's consider water. Water can flow. Consider a gas state, example, that is the air. Air also can flow. So that means combination, if you consider liquids as well as a gas, we can call it as the fluids. Okay. And these gases as well as the fluids are nothing but liquids have a weight. Therefore, liquids as well as the gases also exert a pressure. But in all the direction, the liquids or fluids exert a pressure. But in case of a solids, okay, in case of a solids, the pressure is exerted only at the bottom in which they are in a contact. Okay, only at the bottom, or else the place where the objects are in contact. So there is the only place the pressure exerted by the solids. But in case of fluids, they can exert in all the directions. Okay, in all the directions. See, all the liquids and the gases are fluids. Okay, this statement is very important. What are the fluids? Fluids is the substance which can flow. The substances which can flow. A solids exert a pressure on the surface due to its weight. Similarly, fluids have a weight and they also exert a pressure on the base and walls of the container in which they are enclosed. Pressure exerted in any confined mass of the fluid is transmitted and diminished in all the direction. Means in all the direction the pressure will be same. Okay, pressure will be same in case of fluids. Got it? Now, next case. Buoyancy and the weight of the body. Okay, so these two terms are very, very important. First, already we know that what is weight. Weight of the body is nothing but a force by which earth attracts towards it. Okay, so that is the weight of the body. And what is the benefit of that weight? What is the weight to do? Weight of the body has a tendency, okay? Weight of the body has a tendency to sink a body to the bottom of a liquid. What is this, sir? Let's consider example. Let's consider with example, okay? So this is the container, okay? Let's consider a container and here water. Here water. Let's consider one more object, okay? So it has a weight, okay? It has a weight because of the mass, okay? Because of the mass. So this weight, what does it do is, it has a tendency to sink the body to the bottom. Means this one can sink the body to the bottom. So this is the final state of the body, means place of the body. So weight of the body has a tendency to sink the body. See, weight of the object. Weight of the object is the force with which it is attracted towards the earth. It has a tendency to sink the body in a liquids. Okay, when we kept a body in the liquid, it has a tendency to sink the body to the bottom of a liquid. But what about a buoyancy? This buoyancy is also type of a force. See, weight is also type of a force, thrust is also type of a force, and here buoyancy is also type of a force. But it is due to fluids. Okay, let me consider example of air. Okay, air is a fluid. Okay, so when you take a paper and just throw it, it do not come directly on the floor. Okay, it do not come to the or else do not reach the ground directly. First, what will happen? It will be floating. After some time, it will come to the ground. So why it is happening? Because the force due to air, it is exerting in vertical upward. Okay, vertical upward. In the same way, let me consider a water bottle. Okay, so first what you have to do? First you have to empty this water bottle. Okay, first you have to empty this water bottle. Then what you have to do? You have to put this cap and you have to take care. There should not be any gap, means air should not enter. Okay, so first you have to keep it very tight. And what you have to do next? So take this water bottle and try to push inside the liquid. Okay, so due to your force, applied force due to your hand, it will move inside the water. Okay, try to push it down, means to the bottom. Okay, and after some time, when the water bottle inside the liquid, okay, remove your hands. What happens? This water bottle will be coming upward. Yes or no? Okay, try to push it again. Again, it will come up. Why? What is happening? The reason, simple. The liquid is also exerting a force in a vertical upward direction. Okay, the force exerted by the liquid is called a buoyancy, or else force of buoyancy. Okay, and it has a tendency to move the body up. Okay, to move the body up. Got it? Now, so buoyancy is the type of force. Okay, again I'm telling you, buoyancy is the type of force. The force exerted by the liquid in the direction vertically upward, but weight of the body towards the center, means has the tendency to sink the body in the liquid. It has a tendency to move the body upward. Got it? Okay, so that means based on okay, based on weight of the body and buoyancy force of a liquid, okay, FB. F base B, buoyancy force of a liquid, okay, force of a buoyancy, okay. Relation between these two will give you whether the body sink to the bottom or float on the surface or submerged between the surface and the liquid. Okay, shall we see that? Special cases? Yes. The first case, why object float or sink when placed on the surface of water? So reason, relation of buoyancy force and weight of the body. Okay, weight of the body it is given by mg. Buoyancy force of the liquid it is given by rho vg. Means this force of buoyancy is also depends on some parameter. Those are density of a liquid. Okay, here I'll write density of a liquid. Density of a liquid. Density of a liquid. And V is the volume of the liquid. Volume of the body. Okay, volume of the body. And G is already we know that acceleration due to gravity. Acceleration due to gravity. Due to gravity. Okay. Buoyancy is the force exerted by the liquid in the direction vertically upwards. It has a tendency to move the body upwards. It is given by rho Vg. Okay. Next, the weight of a object. Weight is nothing but it is the force. Okay, acting on an object. Force with which it is attracted towards the earth. It has a tendency to sink the body in the liquid. In the liquid. Okay. Now, let's see the special cases. The first one. Okay, first case. First case, the weight of the body, that is W, is greater than buoyancy force of the liquid. Okay. So when weight of the body is greater than buoyancy force of the liquid. Greater than buoyancy force of the liquid. So initially what I'll do, I'll take the body. Okay. A round shape only. It's up to you. Okay. Whatever shape you want, you can take. No problem. Okay. Now let's consider this is the body. Okay, this is the body, and due to weight, okay, on this body there will be two forces are acting. One is weight of the body, okay, another one is buoyant force of the liquid. Okay, this is a buoyant force of the liquid and this is weight of the body. When you keep an object on the surface of the water or else a liquid, let me consider surface of the liquid only, water, example water only I will consider. Okay, so what happens is, for this condition, as weight of the body is more, what happens, it will move downward because it has more tendency. So therefore what happens to the body, it will move downward in direction. Therefore finally the body will sink. Finally the body will sink. Finally body is at bottom. Okay, so here the condition, what happens, body sink. Okay, right. Next case, if the weight of the body is equal to the buoyant force, means buoyant force and weight of the body are equal. Again I'll consider same body. Okay, same body on the surface of the liquid, and we know that there are two forces are acting. Okay, there are two forces are acting. One is acting downward, another one is acting upward. And if we consider this is weight of the body and this is a buoyant force of the liquid, and what will happen is this body will be submerged. Submerged means just inside the water surface. Okay, just inside the water surface. Okay, just inside the water surface. So here you can see weight of the body still acting downward and buoyant force of the liquid moving upward. FB and weight of the body. Okay, so here body submerged. Submerged means it is cannot be floating on the surface of water. Okay, and it cannot be sink to the bottom. Means between, okay, just below the surface of water, it is floating. It is not a sinking or completely floating. It is the submerged, means just below the surface of water, it is a submerged. Okay. What happens if weight of the body, okay, if weight of the body is less than buoyant force of the liquid? Okay, buoyant force of the liquid. Okay, buoyant force of the liquid. Let's consider. So this is the body. Okay, this is the body, and again, on this there are two forces are acting. One is upward force, another one is downward force. Downward force we call it as the weight of the body, and upward force we call it as the buoyant force of the liquid. Okay, now, so here you can see it is a floating. Okay, it is a floating based on, okay, based on volume of the body and density of the liquid, the submerged part will be decided. Okay, submerged part will be decided. So here weight of the body and buoyant force of the liquid. In this case, weight of the body is less than buoyant force of the liquid. Okay, so it will be floating. Okay, the body will be floating. Simple. And this floating and sinking concept can be explained with the help of a density also, density of a body and a liquid. So based on that also we can explain the body sinks or floats. Okay, right now we are explaining with respect to weight of the body and buoyant force of the liquid. Got it? Now, Archimedes principle statement is very important. Archimedes principle statement is very important. The statement is simple. Second case, that is W is equals to FB. That is the statement of Archimedes principle. Okay. Now, weight of the floating body is equal to the, okay, weight of the floating body is equal to the weight of the liquid displaced by its immersed part, that is buoyant force. Okay, weight of the body, floating body, that is equals to buoyant force of the liquid. This is the statement. What does it mean? Second case, you see here the body is initially it is a throat on the surface of water. What happened? It is floating. Okay, not completely. Okay, not completely sink to the bottom. It is a floating, some kind of, okay, and this weight of the body will be equal to the displacement, displaced water or liquid by this body. Okay, so there's a weight of the body as well as a displaced liquid. All these you are going to learn in a class 11th fluids concept. Okay, just you have to know what happens if FB and W relation. Got it? So that's all you have to learn. If W is greater than FB, the body sinks. If W is less than buoyant force of the liquid, then it is a floats. If W is equals to FB, then it is also float, but it is a submerged just inside the surface of water. So that W is equals to FB case, we call it as a statement of Archimedes principle. Got it? Okay. Now let's move on to the applications of a flotation. Okay, application of flotation. So here we have a few applications of a flotation. The first one, flotation of an iron ship. Next one, flotation of a man. What is the reason for that? Okay, if the flotation of iron ship, if we consider entire weight of the a ship is less than the buoyant force of the liquid, that means buoyant force is more in this case. Okay, in all these cases, weight of the body, average weight of the body, okay, average weight of the body is less than buoyant force of the liquid. Therefore, it is a floating. Okay, in all the cases. Flotation of a man, flotation of ice water and a submarine and iceberg, next waves and balloons. Okay, so all these are application of a flotation. Okay, and you can write any two applications of this flotation. And after the lecture, what do you have to do? So first, revise the today's lecture, highlight important concept or questions, then note down, okay, your doubt if any, okay, in your notebook, so that we can ask in a next class. Okay, So that's all for today's session. Then we'll meet you in the next session with a new chapter. Till then, take care. Bye-bye.